This is Mark Levin, in charge of almost all aspects of the code and coordinating with the networking. Him and Steven. Steven was lead coder, Steven Cento. They were sort of the heart of it. And then we had a third coder who was just on the UI, and then a networking coder who was just on the networking. Mike Watson in the back, he was our QA lead. And the guy driving it was one of our testers. That's Matt. Okay, does anyone have any questions? What? Yes.
Well, I guess, did you start off with the open source engine that was provided by Bungie, or did you just build it from the ground up? Like, how did you reference the original game and keep it as awesome?
I'll let Steven talk to that, but we didn't use that. We actually used the Windows source, not the ALIF1 open source engine, mostly for copyrighting.
Okay, well, legal issues with the open source engine aside, the first thing which is kind of interesting to note about it is that the open source engine uses obviously a lot of libraries that aren't available on the 360. So that's the first aspect. We'd have to port all those libraries out, even if we could use it. Second of all, as we said, we really want to take advantage of everything the Xbox 360 had to offer in the way of just increased computing power, the very powerful graphics card it had, and all this other stuff. So taking what was essentially a Windows and Mac and Linux-centric open source project and then pulling it out and threading it and then adding all the Xbox-specific libraries and then going back and taking what's essentially a weird implementation of OpenGL, direct draw stuff, and making that compatible on the 360 was just something that we realized that even if there was some legal way to get this, it would actually be faster and better if we just sort of stepped back and wrote this all from scratch. As far as maintaining the game to be original, basically the way that it works is we have a game thread that has all the original logic on it. It's been tweaked slightly for running at 60 frames a second instead of 30, but it's all the original logic, pretty much copied, pasted right out of the Windows source. Whenever it goes to do a sound operation or goes to do a rendering operation, there is a rendering thread and sound thread and network thread that sort of take that off, and that's where the 360 heavy lifting stuff goes on. So essentially, the game code is naive to the fact it's running on the 360. The rendering thread and the sound thread just do all that abstraction for it.
Two questions. Were there any features and components that were particularly harder to do, networking aside, when you built the 360? Is it just a sort of part of that is when you get to the, I played through this game a little bit, but when you get to the end of it, some of those textures are pretty tricky. And I was wondering if you were able to get the same look for them in the 360 with a heavier graphics card, because they're obviously hacked for older graphics.
Well, if the original Alien texture set, which is in fact a little bit trippy, I think anyone who's played the original game can attest to that. Basically, that was just, we upscaled the assets and we made the new high-res assets look pretty much identical to the originals, only there's more fidelity. So what kind of looks like, maybe a red, blur is a little bit more fine. You can find it's, actually a nice curve, a metal curve. But as far as the actual graphics heavy lifting, that actually wound up being a little bit more of a problem than we'd initially realized, because the original game engine was a portal engine and allows you to do things very much like the way that Prey does things, with rooms that are not linear, rooms inside of rooms inside of rooms inside of rooms. And this sort of happens casually throughout the game, and you never realize it. So we actually had to support this modern functionality in this type of an engine. And the thing is, where Prey uses sort of interesting tricks to get around that, we unfortunately actually had to support a portal engine like Duke 3D. It really became actually a really heavy lifting challenge, that this scene that you see here, even though it's really, really simple, is actually a few thousand draw calls. It is actually really complex, and there's tons of clipping planes involved, and if I was going to go even further, I'd go to Mark, because he wrote most of that, I have to confess.
How did you handle the localization?
Ooh. You want to take that?
Okay, localization is kind of interesting because as a single language speaker, there are a lot of things you don't think of, like some languages run right to left and some run left to right. Also, one of the things we ran into was that you can't use the same font for every language. So that had to be dynamic. We have at least 2 fonts in there, and they get loaded depending on what language you're in. This sort of cascades over into how you draw the text because we're not literally using a font, we're using a collection of bitmaps for each character. And each language has a different set of characters that it may have to use. And this, it's not all that difficult to implement on the programming side because the Xbox has a very nice service for keeping track of all this. But on the content side, it just magnifies problems several times over because one of the main problems we ran into, not to say anything bad about the Microsoft Loc teams, they did amazing work and it all turned out great, but getting them all synchronized, if we came up with something we had to notify them of, we had to notify them all of and keep them all in sync with each other. And sometimes that would happen inside Microsoft and it would spill over to us and vice versa. And generally, localization just increases the amount of work you have to do on your content. It adds a great deal of time, especially to testing, as I'm sure Mike could tell you.